Welcome, everyone, to the AI in Construction webinar series. Today, I'm really excited to have Michael Fleischman, CTO of Openspace AI. Michael's got an amazing background. He's forgotten more about AI than I'm ever going to know. And today, we're going to go through how Openspace, excuse me, I know, has been using AI from the very beginning. And one of the things that I talk about sometimes is the different flavors of AI, and they were using AI before it was cool. So with that, Michael, do you want to say a quick word about kind of a little bit of background? And I'm going to switch so it's just the two of us, two of our smiling faces.
Sure, I can introduce myself. As Hugh said, my name is Michael Fleischman. I'm CTO and co-founder of Openspace. If you're not familiar with Openspace, we are a reality capture company founded probably about 7 years ago with myself and two of my co-founders, Jeevan Kalanithi, our CEO, and Philip DeCamp, our chief engineer. The three of us are old friends from grad school. We've known each other about 20 years now, actually, so long time back then. My background, as Hugh said, is in artificial intelligence, actually coming into it from the world of cognitive science initially. In grad school, I was studying AI, really initially trying to build models of the meaning of words. That was kind of the focus of my degree, and in particular, looking at how words get their meaning from vision. And so my initial work was really looking at the combination of vision and language. I actually started another company coming straight out of grad school with my advisor. It was a company called Bluefin Labs, very different, not in the construction space. That was actually looking at social TV analytics. So what we did there was combined computer vision on the one hand to look for what was airing on broadcast television, so like what TV shows and advertisements. And then at the same time would mine Twitter and Facebook data, looking for when people were talking about those TV shows and ads. So combining vision and language together. Ended up selling that company to Twitter, where I was working for a number of years, doing a bunch of different things, mostly with the CTO there, working on different projects, mostly around growth. And then started Openspace, really coming out of that, really to solve a real world problem that I was having at the time. I had been in Boston this whole time, as Hugh and I were just talking about before we started, and was finally ready to come back to California and was trying to find an apartment remotely, and was having a really hard time. Every time I would look at something on Craigslist or Zillow and see the pictures.
Never mind. It was on speakers.
Excuse me.
Sorry.
Go ahead and mute. Thanks.
Sorry about that. Having a real hard time finding an apartment remotely. And the challenge was that if you're just looking at pictures that were just kind of, on a website of an apartment, I was realizing I had no idea what the apartment actually looked like. There was no spatial context for each of those particular images. And what I really needed was more of a kind of virtual walkthrough to be able to see what it would be like to be there. So maybe you've had this problem like on Airbnb, looking at pictures for a vacation rental or something. So this was the kind of core problem Openspace was started to solve. Originally kind of aimed towards the real estate market. But fortunately, Jeevan, who had a bunch of experience in construction, realized that there was probably a even more interesting problem to be solved in the construction world. So we kind of shifted gears and got into the construction space. And so if you haven't used the product before, the way it works is that we use these 360 video cameras here. So this is just a camera. It has two lenses, a 180 fisheye lens on each side. And so what it does is it creates a 360 spherical image. And as you're taking video, what's happening is it's taking these 360 spherical images, every half second or so as you walk around a space. And what our technology does is it really takes each frame of video and localizes it really specifically onto the floor plan of your buildings. Makes it really easy to find those images later because you know exactly where they were. It also makes it easy to create these 3D models of your environment. And that's kind of how it works. It kind of is like GPS for the inside of buildings, even though real GPS doesn't work very well on the inside of buildings, and that's kind of the core aspect of the technology. Um, Kind of similar to how self-driving cars work in terms of how the technology actually works, by building these 3D models and kind of mapping them onto the space. Of course, construction just makes everything so much harder because the walls might not be up when you're trying to map it to your floor plan. And so we end up having to developing a lot of specialized algorithms in order to solve that kind of GPS inside of buildings problem.
And actually, I'm really glad you ended there, because I think what would be cool is to talk about some of the technologies that are obviously versions of AI or flavors of AI, maybe even starting from the beginning, like things that have been around a little while, like SLAM, that allow you to start the process of even doing that mapping, making a photo kind of map to reality. Do you want to talk a little bit about some of the technologies you guys are using now, and we can get to the more advanced stuff later?
Yeah, so SLAM is a great example. It's kind of an example of one of the technologies that really is being taken advantage of in self-driving cars. Simultaneous localization and mapping is what it stands for. But the basic idea is, as you move around space, we're trying to take each frame of video and find correlations between each one. And then once we find kind of matches between, so like a part of a door frame in one video, part of a door frame in another, we can keep track of those. And as you go through the video, kind of stack them all up on top of each other. And then after a while, you start to develop this kind of actual model of the environment. Not quite a BIM model, not quite that abstract, but kind of very similar to that. And SLAM actually is a kind of specific family of algorithms that live within a kind of larger group of algorithms, often called spatial computing algorithms. So spatial computing is a term that you actually might have heard of in the context of virtual reality and augmented reality, probably mostly because Apple has kind of co-opted that term to refer to their virtual reality, glasses, their Vision Pro glasses. In fact, I think I read somewhere that if you build an app for the Vision Pro, you have to call it spatial computing. You can't call it virtual reality, although I don't know if that's 100% true. But spatial computing is actually a much larger term, and it goes back to at least the 80s in terms of when it was first used, originally in the context of GIS systems, geospatial information systems. So back to GPS, actually. And really what it refers to is just any type of algorithm that is really incorporating spatial information into the environment. Spatial context is one way to think about it. And our algorithms in particular borrow from a number of these different spatial computing algorithms, but the real secret sauce in what we do is that our spatial computing platform is really a learning platform, a host of learning algorithms. So every time you walk through your job site taking video, we actually are learning about your environment as you walk through that job site, so that the next time you take a walk, we're getting a little bit better each time. And in fact, across multiple job sites, we collected over 3 billion square feet of data since the company has formed. And that data set of 3 billion square feet forms the kind of foundation for a lot of these algorithms. And really the reason why it's so fast and easy to use Openspace is because it's powered by that spatial computing learning platform.
And if I may, one of the things that people may remember is the HoloLens that Trimble did some things with, and other folks have done some things with. That uses some of the same family of algorithms, right? So again, you guys are innovating on a pretty rich set of algorithms that have been around, to your point, for at least a decade, but depending on what you're talking about, longer than that.
Absolutely, yeah, yeah. And of course, one of the challenges, even with the HoloLens, which is a great tool, is being able to really localize yourself in an environment. Again, this kind of notion of spatial context. And so that aspect is the thing that we've solved, where when you're inside of a building, you don't have access to GPS, you don't have access to Wi-Fi to triangulate your position. And so a lot of the work that we do has come into, well, how can you find the location of somebody when they're inside of a building, taking, a lot of information from video, but also all the other sensors that you have on your phone as we do that.
And so that kind of implies then that, SLAM may or may not mean you built a permanent model. This implies that you are, right? And that you're remembering. It sounds like that's some of the things that you're learning gets better and better at, is as you walk through, it's creating a 3D model that's bigger than just the room you're in, but it's actually builds on itself. Is that right?
That's absolutely right. Yeah, yeah. Although it's not a static model, and that's one of the really interesting things about construction is because by definition things are constantly changing. So even if you have a perfect model on one day, the next day you go to take a capture, things will have changed. And so part of the learning is also adapting to the environment as the environment is changing around you. But one of the very cool things about that is at the end of your project, what you have is this record of how it's changed over time. It's almost kind of like a history of the project that you can go back and forth and see those changes. Learn from them like our algorithms do so that you can do a better job next time, but also just to have that record, just in case you ever need to go back and find something in a specific place at a specific time.
Yeah, I think that's what a lot of your customers say. You saved me a bunch of money because I went back and said, no, it was that way, not that way.
That's definitely one of the top use cases, although a lot of customers and a lot of our kind of future product directions are about more and more, not just kind of going back in time, but also just how you can use that information to improve the workflows that you have for kind of the right now. And so another area where having that information can be really useful.
Well, before we move into that, a couple more terms I want to kind of situate in this. And one of them is computer vision, which everything you just said implies that's what we're using. How does that relate to SLAM and how your product does what it does?
Yeah, computer vision is it's a good question, and it's kind of you can think of AI as like a tree of different kind of subcategories. So AI in general refers to a whole lot of different types of algorithms. Some of them learning algorithms, usually referred to as machine learning. Some of them not necessarily learning, so kind of things that people have hacked together in order to make work, but still considered intelligent or artificially intelligent. Computer vision is a kind of another way to look at it. Really, it just means any of these AI algorithms that are focused on problems of vision. So anything using images or video, anything like that is going to be considered computer vision. Within that, you have a division of kind of learning algorithms like machine learning or non-learning algorithms that are really based more on kind of geometry and analytics. SLAM kind of lives mostly on the non-learning side, although a lot of newer approaches are taking advantage of machine learning as well. Our approaches are really a combination of all of these different things, and we're really kind of going beyond a lot of the computer vision and SLAM work that's happened in the past, largely to make things work in the real world. And having spent a lot, perhaps too much time in school and academia, a lot of the stuff in papers just doesn't work when you put it in the real world. And construction, again, is kind of one of the most challenging areas because it's a real world that's constantly changing, even more so than a city street, which is relatively static compared to a building under construction.
Well, one of the things that this makes me think of is that people will sometimes think that the AI is one thing. When a real product, you're often using multiple models or multiple approaches. Is that what I mean, you almost said it already, but is that how you guys look at it? Is you're kind of using the right tool for the right part of the job?
Absolutely. No, I think that's a very good way to think about it is you really have to bring all the tools you can to solve these problems because even just kind of when you're walking around a building and you walk through a room that might not have proper lighting, that's enough to throw any traditional SLAM system, make it go completely crazy and not know what to do. And so a lot of the way that we build our algorithms is exactly as you said, finding different algorithms from different types of artificial intelligence, pulling them in and seeing how they can all work together to solve, this larger problem.
And do you usually put an AI at the top of that, or does it depend, or is there kind of more classic software at the top that's taking those inputs?
Yeah, I guess at a certain point it gets a little hard between AI and non-AI. We definitely take a lot of advantage of AI, and that's certainly in my background. So I guess to answer that question, I would say, yeah, really primarily AI approaches, but even inside of AI, when you get down to anybody's AI system, there's going to be non-AI hacks in there that are just kind of making it work.
Yeah, when you don't need AI to put up a user interface. Like, so there's going to be.
Well, that's a good point. Yeah, I mean, there's a ton of stuff that we've developed, especially going back to these workflows that we're optimizing for our customers that are just, in some sense, kind of traditional software workflows, but they can be super powered by AI, right?
Yeah.
And so a lot of the work we do is thinking about how AI can be combined with workflows that already exist, just to make them faster and better, as
Yeah.
opposed to completely, recreating them.
Well, and dealing with a fuzzy world, right? I mean, that's what AI excels at, is it doesn't have to be lines and columns like classic software.
That's right. Yeah. And that's really how we can get around some of these problems that we see. Even applying classic AI, you need other types of AI to buttress it.
Actually, again, great transition, because what I was going to ask you is, some of the tools we've just talked about have been around for at least a decade, in some cases longer. But we're having a webinar about AI because the world's kind of is a different place. Want to talk a little bit about what changed?
Yeah, well, I think you're probably talking about language models when you talk about things that have changed. And I would definitely say that in the last year, the stuff that's come out over that time has been really impressive and surprising. I mean, some of the capabilities that these language models have are things that I didn't know if I'd see in my lifetime. And so, but upon reflection, I at least kind of point to a couple of things that have changed over time that have really kind of made this technology happen, really accelerate in the last year in particular. And some of it does go back pretty far, like back to kind of probably start of the internet times. And so, I think of kind of three factors that kind of drive that in particular. The first is just the availability of data, and in particular, digital data. So data that computers can use, right? And so since the late 90s, maybe late 80s, mid 90s, as the internet's really started to take off, just the amount of data that has become digitized is just really incredible. I mean, pretty much probably every book that has ever been printed is now digitized in some form and machine readable. And then more data is constantly being created all the time. And so the fact that all that data now exists in a way that machines can use it is one trend that this AI boom has definitely taken advantage of. The second one, which is I think related, is just computation costs and speed. So computers in general have just been getting faster and faster, cheaper and cheaper. Again, since probably earlier than the 90s and 80s, even since then. Which you can just see in like the power of your smartphone today versus a smartphone 10 years ago, or a desktop computer 20 years ago. It's just faster and faster and cheaper. And GPUs, graphical processing units, what power video games, is like another kind of revolution and example where it really kind of upped the ante in terms of how fast these relatively cheap computers can be. So the third piece, though, is probably the thing that was kind of most surprising and probably most relevant there, is that even more than a year ago, probably closer to like 5 years ago, there were a couple of innovations around designing algorithms, AI algorithms, learning algorithms that were invented. A family of algorithms called transformers, which were very cool and had, amongst other kind of cool characteristics, one in particular is that they enabled you to start learning off of multiple machines at the same time. So kind of distributing the learning problem across multiple machines. So kind of before that happened, if you wanted to build a AI system that learned off of data, you kind of were limited by how much physical memory your machine had, how much data you could put on a single machine. What the transformers did is they figured out a way that you could actually split that up across multiple machines instead of relying on physical memory. So you're no longer kind of limited by physical memory. Now you're really only limited by how much money you're willing to spend to buy machines on Amazon, right? And so this is why you read these articles about Meta or Google spending billions of dollars to train these systems. What they're basically doing is they're just buying or renting these machines to process all this data that has suddenly been available or is now readily available, and just doing it at a scale that nobody thought was possible, 5 years ago. So, data availability, powerful, cheap machines, and then these new algorithms that let you take advantage of those first two, and then kind of like magically a year later or a few years later, you have these language models that can do amazing things.
How do transformers make generative AI possible, though?
Well, it's really interesting, actually. So generative AI, again, another subtype of AI, really just refers to AI that generates content. So generates text or generates images or video or speech. Anything that's generating content in particular is generative AI. And what transformers did is they actually enabled what is a kind of a surprisingly simple little machine. So what transformers are doing under the hood is all they're really doing is just trying to predict the next word in a sentence. This is for text in particular. So they're given, billions of lines of text of natural language to train on, and basically the system has just shown the first part of the sentence and then said, what do you think the next word in that sentence is going to be? That's all it's really doing. And what is amazing about that is that just by doing that very simple model, and then of course splitting it on billions of dollars worth of machines and all this data that exists from essentially all the history of human thought, and it's actually able to encode not just a ton of general knowledge, but actually a lot of common sense knowledge as well, right? So the idea that if I have this cup here and I let go of it, what's going to happen in the real world? That type of knowledge is not necessarily written down anywhere, like what happens when you drop a cup. It's thought of as a more common sense knowledge that you get just from kind of living in the world. And the amazing things about these, they're called foundation models that these transformers are actually building, is with this very simple trick, just predict the next word in the sentence, they actually start to encode that common sense knowledge. And this is a huge problem in the world of AI that people have been trying to solve for probably since the beginning of AI, that just kind of emerged out of these foundation models.
Awesome. Well, that kind of gets us to the topic of today, which is that, now we've kind of laid some, and I really appreciate your diving deep on this, is what do you see next? I mean, we're talking about spatial AI, so I'm giving that one away a little bit, but how do you see that kind of being the obvious next, or not obvious, but the next place that we're going?
Yeah, spatial AI is definitely how we think of it, and really kind of maybe a more general way to think about it is just kind of the next step is integrating space and time into these algorithms, right? So we've been talking about language models and generative AI, mostly in the context of text, and I think that's where they're kind of most impressive right now. When you go to ChatGPT, you ask it questions and it answers like a person. That's the bulk of their training data is actually text. That's kind of where most of it is. In fact, what I've read, that probably the most advanced of these language models probably have been trained on all of the text that exists in the world. So there's like no more text for them to work on. Now they also are doing images and video, and they've been making really pretty impressive and rapid progress on that as well. GPT-4o, for example, is pretty impressive in what it can do with images. But even those models have no sense of spatial context for the images that they're given. That idea of where is this image in relation to other images, in relation to you, in relation to time, when was it taken versus something else. Now, this notion of spatial context is actually very critical for like a whole suite of problems or tasks that we have in the world. Anything that you need to do in the real world. So domains like manufacturing, robotics, and of course, construction, the ultimate real world task. All of these areas really require information about the space, where these images were taken, if you want to do anything with them, right? So if you have an image of a defect and you think it's actually in the wrong place on your job site, that can actually be counterproductive, right? Even worse than not having the image if you actually think it's in the wrong place. And so these language models right now have no ability to reason about that. If they see an image, they have no idea where it was taken on a job site. And that integrating that information is really the kind of next phase in our mind, particularly for construction technology. And really when we talk about spatial AI, talking about that kind of integration right there.
And I mean, some of what, just connecting some dots here, where you were talking before about how as people walk through job sites, the system learns. It sounds like what you're also talking about is almost the spatial common sense, right? Where it starts to understand the space as space, not just a series, like an image might be a series of pixels, but okay, it doesn't need to understand much more than that to do image recognition. But with space, now you're talking about relations that are in 360, 60 degrees.
Yeah, I like that actually. I might steal that spatial common sense. I think that's a cool term. Yeah, and I think the addition what I would add to that is the context of time as well. So again, because we're enabling captures to be so easy to do, and really kind of usability and ease of use and speed is really kind of one of the things that we really optimize for. It really encourages people to take captures of their job site on a very regular basis. And so one of the advantages of that is that you can also look at the context, not just that this image is in a particular place, but these two images are looking at the same thing over time and how that changes. And that becomes super valuable for a number of workflows in construction, looking at reporting progress, identifying defects, things like that become, enabled, but only if you have that temporal, that spatial context, that spatial common sense, like you said.
And one of the things we like about AI is it does inference. So you also finding that the world's a messy place, and to the point you made before, lighting can change and angles can change and all that. And that's one of the things AI can be good at, is being invariant about what some of those variables. I actually said that out loud. How are you finding that over time, again, you're just getting better and better at recognizing things because again, you're only seeing a part of whatever it is, whether it's a switch box or you name the thing. Are you getting better and better at recognizing things so that you can be more accurate when, again, it's by definition messy?
Yeah, we certainly are. And the key to that, again, is really the data. Just like the generative language models that we were talking about, the key to their success has been this large amounts of data that have, kind of been growing over time. For us, having access to that 3 billion square feet of data in order to train these algorithms is part of what we're constantly coming back to. How can we use this data to improve our algorithms, whether it's kind of recognizing the same objects from different angles, or just doing a better job of lining ourselves up. Are we in the same place today as we were yesterday? How do these images relate to each other? All of that kind of gets better by taking advantage of that data. But it's definitely not a solved problem, I will say that. And so it's getting better over time, but it's still, a lot of technical challenges to do that. And it's really, if language models just came out a year ago, these spatial AI approaches have even less history in terms of kind of their development on the curve.
And so, thank you. How do you see this kind of coming together with some of the other things that we're talking about, whether it's, agents and so on, but like, how does this kind of come together?
Yeah, agents is something that we think a lot about, actually, that term and what it means for a chat bot. I've actually been kind of digging back into my AI history books a little bit recently, and there's a character there, a guy who goes back way to the beginning of the founding of AI back in the 60s. This guy, J.R. Licklider, who's not the most well known, but wrote a really interesting paper back then called Man-Machine Symbiosis. And what he was talking about, yeah, it's a cool name, right? What he was talking about there is really this notion of an agent and how it differs from how I think many people back then, but even today, really think about or thought about how AI will kind of, come into use case, come into life for us. And so, back then, the term computer, I don't know if you know this, but the term computer, I didn't know this, actually refers to originally a job that humans used to have. People would, be hired to be computers, and what they would do is essentially do math problems, like for, accounting or actuaries and stuff. Yeah, exactly. And so I think kind of traditionally in AI, when it first came about, the idea of AI was to replace those jobs, right? To build machines that could do those jobs of humans. What this guy Licklider was saying in Man-Machine Symbiosis is that that's the wrong way to think about AI. And really the way to think about AI is to build agents or chatbots or whatever you want to call them, assistants that will work with humans so that the humans can do their jobs better, faster, more efficiently, just in better ways. And that kind of idea of machines working together with humans to work faster as opposed to replacing them, I think is very relevant in construction, where honestly, very hard to imagine any successful AI replacing the job of a worker on a construction site. But the idea of AI giving them superpowers, almost like a digital exoskeleton to let them do things that they couldn't do before or faster, that type of interaction model, I think, is very appealing to us and is very much kind of baked into our approach for product development, as well as technical development as we dig into spatial AI.
Well, that's I love that you brought that up. And this idea of augmentation. I mean, I think there's two directions it goes in, right? One is the idea of superpowers. The other one being the low level eye rolling stuff that people hate doing, like paperwork and so on, which is near and dear to my heart. How do you guys think about what tasks? And the other thing I hear people say, which I think is really helpful, is rather than think about jobs, think about tasks. Because then it's like, I'm going to peel away things either you don't want to do because they're tedious, you couldn't do because there aren't enough hours in the day, or whatever it might be, or other things like that's just too much detail for a human mind to handle at once, whereas AI can. How do you guys think about that?
Yeah, well, it starts to get pretty specific, right? As you think about the individual jobs that you're talking about on a job site, and the variety of workflows and paperwork that flows through even the field teams, right? And we actually really focus on the field teams in particular at Openspace as a place where we think they could get the most value out of the technology that we're building. But the kind of core to that, the kind of higher level there is really this belief in a kind of what we think of as a new way to do construction that we are really on board with. Image first construction tech is kind of how we think about it. And so this idea of image first, again, we're borrowing from the history of technology as a kind of almost an evolution of where things are going and where things have gone. So kind of like the first wave before image first was really digital first, right? And what that refers to is this move from paper to digital text, right? So basically, instead of writing things down on the job site in paper, you started to use Microsoft Word and spreadsheets like Excel, right, in order to kind of digitize the workspace. And what, very powerful, a lot of efficiencies there. But that kind of first wave of technology was then quickly followed, particularly in consumer, by an image first approach, the move from text to image, right? And so you can see this in everything from like MapQuest, if you remember MapQuest, going from MapQuest to like Google Earth or Street View as an image first approach to directions. Or more recently, like what started with Facebook and Twitter is like text social media, going to Instagram and TikTok and Snapchat as like a image first and then video first approach to social media. And so we believe in the same kind of evolution happening in construction tech. Initially from, drawings on paper, then to digitized on, your tablet or your smartphone, but then moving from just digital text workflows to workflows that are really based primarily on the images themselves, right? And again, it's really basic, just like the expression, an image is worth 1,000 words. Taking a picture of a defect on a job site and sending that off to somebody, that's already happening today. It's just happening with smartphones and text messages, and it's very inefficient. Again, because that data doesn't have that spatial context, right? So kind of connecting this to your question, the reason for spatial AI is really the reason for our focus on spatial AI is really to power this move towards an image first kind of workflow solution, so that you can actually take full advantage of the images and the video that you're able to capture on your job site and actually integrate that into the workflows that you're already doing today, again, to make them faster and easier.
I love that. And it's harkening back to your cognitive science, right? The highest bandwidth way to communicate with a human is the visual cortex, which is what, like 1/3 of our brains.
Totally. Yeah, it all comes back to that.
When you start, interestingly, are you starting to learn that some ways of presenting a thing or some ways of using images are better than others, or people spend more time? I mean, the cool thing is you can't tell what's going on in someone's brain, but modern analytics mean you can start to learn this is more effective or people are using this more. Are you starting to learn a little bit about the human side of it as well?
Well, it's interesting. We definitely learn more, and this is a place where I think we'll continue to learn more. And again, it kind of goes back to that 3 billion square feet of data that we have, because that is what really kind of starts to unlock things. And starting to look at, for example, what are the images that people spend the most time looking at, right? And analyzing the kind of viewing behavior of these images, and they're kind of stepping back into what people are attending to. And then you can start to combine that with outcomes on the job site as well, right? And this is kind of one of the holy grails of the data that we're creating, is how can you start to move from just looking back in history in case something goes wrong, and then kind of working on the present in terms of workflows that are actually happening. But then in the future, predictive analytics. How can you look at images you see today and predict what might happen, what might go wrong, what might need to be looked at in the future? All of that information is kind of hidden in that data that we've collected. And part of the task ahead of us is figuring out the best ways that we can pull that out.
That's interesting. It's almost, we're going from spatial common sense to spatial intuition, right? Because I mean, that's kind of what you're trying. I'm full of them today.
I love it. I love it.
Tip your waitress. But the idea that you're looking at a scene and kind of going up a level in abstraction and saying, I think this means that. I think this means some of these risks might be present and you should pay attention to it. So now you're empowering. This is maybe where the superpowers come in, where the PM or the super is saying, you're saying, hey, you might consider this, because when we've seen this in the past, some of these risks have shown up. Is that some of what you're saying?
Absolutely. And really it goes kind of up and down the stack there, right? So those types of benefits, predicting into the future, that spatial intuition, that's one level. Which is certainly valuable, but even like all the way down into the kind of more mundane things in terms of just the ability to look at, how people kind of carve up their job site in terms of zones of interest, right? Can the machine do a job to help kind of predict what those zones should look like, just to make, one less thing for the human to have to do, right? One less line to draw on a drawing, one less annotation to make. Little things like that. There's actually a number of ways that the spatial AI can be applied to workflows, kind of all through that whole process, whether it's intuiting about the way future and risks, or just kind of easing the processes that happen every day, more like the paperwork example that you gave and getting rid of that. Spatial AI has the potential to really, be applied and revolutionize all different aspects of construction.
You make me think of this, that one of the things we talk about is people, process, and technology. And, I think we are so used to software that is deterministic, and if it's going to do a thing, it does it 100% of the time. AI is more sophisticated, but it's also based on very often on probabilities. So you're finding sometimes that the process, or at least the expectation, has to be changed, where it's like, look, it's really good, but you're asking, it's looking at it at a really fuzzy world, and it's gonna get you 80% or 90% there, but we still need a human very often to say, thank you for that recommendation. Now I'm going to assess whether I use it or not.
Yeah, no, and I think that really gets to the heart of that whole interaction model between humans and AI, in the idea that AI is always, to some extent, going to be an assistant to a human who has to make a decision and has to do something. The AI is going to get better and better, right? Hallucinate less and less, hopefully, but there's always going to be that role for a human in there, because the AI is never going to be perfect. Probabilities, all sorts of other things can get in the loop there. For us, what that really means for us is this idea of grounding out what the AI is doing in the real world, in the images itself. So whenever the AI has an inference to make or a prediction to make, anything like that, the idea is we always want to ground it out back into the images. So the human can always go in there, look at the image themselves, and verify, trust but verify what the AI is saying, so that there's always that kind of level of reality that is accessible. And actually that problem in itself is, or that in itself is a problem that needs to be solved, that we're, actively solving, is what is the reference behind that intuition, right? When the AI says something, what is the reason for it? How can we show that to a human so that they can judge for themselves the truth of it? And that's kind of a common problem all throughout AI at this point.
Well, and the more sophisticated or abstract the inference, the harder that is, right? Because it's obviously drawing on a lot.
I think that probably is true, yeah. And so there's definitely a sense in which you want to start small, and what is the low-hanging fruit that AI can actually help with in the most the kind of simplest and fastest way. And that's just kind of product development, 101 right there, is what's the low-hanging fruit? What is the part of the problem that AI can solve just to make it faster right away? And then build off of that for the more complex inferences in the future.
Once again, with the segues. So what I'd like to do is just ask you one last question, and we'll open up. There's some good questions that folks have come up with. But when you think about how a lot of this is being applied with Openspace, what are some things that you guys are doing that are coming, that you're in the middle of releasing it or have recently? Where's this kind of going with you guys?
Yeah, well, the spatial AI engine that we're building, the way we think of it is really as kind of like a platform, basically like a suite of spatial AI assistants that we want to develop, each one kind of targeted at different specific tasks, really kind of all over the kind of spread of workflows in construction. And so I don't want to get kind of too far into what's not currently out and what's in development, but in terms of areas that we have been really interested in, one area in particular has to do with the smartphone. And so, our core technology has focused primarily on 360 video initially, but the learnings that we get from that have application even to the smartphone, to the 2D photos that you take with a smartphone. And so one area that we're building assistance for is really trying to get at how can we make the smartphone photos that you take on a job site as powerful, as searchable, as findable, as usable as those 360 images we have as well. And part of that is just opening up a kind of democratization of reality capture so more people can be capturing, and also, making it more useful for the photos that you're already taking. So that's kind of one kind of high level direction. Another, which is probably a little bit more general, but just reporting in general on the job site. So all of this information, like you said, is coming in from these images. It's, the visual cortex has the most information gain that you can get. How can we look to summarize that information in a way that's kind of easier to communicate around, whether that be, the progress of a job site or the state of a job site or various other QA, QC workflows that might happen. But basically just applying this technology, this intelligence or the spatial intuition that you're describing to those images in order to help with all of those daily reporting tasks that so many of our field teams have to do. So it's probably a lot of stuff in there in particular, but it's one of our most interesting focuses for sure.
Yeah, it sounds like the more you're able to reason in 3D, it just opens up, you can keep going. Like everything from time and motion, which is kind of a weird one to go to, but understanding how people move or how space is used and safety and so on. I mean, I don't want to be speaking for your roadmap, but the point is, once you start thinking reasoning in 3D, it opens up a lot of interesting things. Here's a flyer. How do you guys think about robotics? Because again, one of the issues that robotics is by definition moving in 3D. Is that something that you guys overlap with, or is it, a bridge too far, as they would say?
No, I wouldn't say it's a bridge too far. It's definitely an area that I think we're really interested in. So, of course, one thing that one kind of application, as you were kind of, I think, hinting towards with that 3 billion square feet of data we have, I think is the potential to model that in a way that robotics could really take advantage of that, right? So that's kind of like what we could give to robotics. But bringing robotics onto the construction site, it's a challenging task, and there are companies out there that have made great progress. Dusty Robotics is one that comes to mind, where they've really been able to find a very specific task that the robots are really excel at, and kind of identify that and kind of really drive to it. More generalized robotics, I think have a lot of potential for, for construction and also for reality capture. But there's still a lot of challenges there to get that actually working on an everyday job site.
Yeah, it's interesting, having spent some time more with AR than robotics, but one of the challenges they often have is registration and making sure you know exactly where something is. And it sounds like at least some of what you're saying is you guys are able to create that context that something could be localized in, whether it's AR or a robot or whatever. It just has a way more accurate sense of what's around it than would be true if it were just using imagery or something like that.
Yeah, I absolutely. GPS for the inside of buildings is a ton of applications, and I mean, one of the challenges for us is picking across all of these really interesting application areas for the things that we think are going to drive the most value for our customers in the soonest time horizon. And so yeah, I think there's a lot of cool stuff we could do with robotics, but it's probably not in our super near term roadmap.
Yeah, or someone partners. So I'm going to go to some of these questions, which I'm going to have to read this one verbatim.
Okay.
Timothy says, I'm curious if AI can resolve what he calls path reconciliation. They've learned that it's helpful to try to do captures on successive dates by trying to follow the walking path. Okay, of previous captures to the greatest extent. That sounds like something that you guys have solved, but you kind of get his point is, what if someone doesn't walk the same way? How are you keeping that registration?
Yeah, so for our technology, it doesn't matter. One of the ways that we realized kind of one of the requirements we realized early on in the company is that in order to make this easy to use, you really have to allow people to walk wherever they want to walk. You can't kind of instruct them to do that. And so our technology doesn't require that. Of course, it takes advantage of it if that is the case, if you're walking the same paths back and forth. But it uses, it doesn't make any assumptions about that. And so it's been really tuned and designed to avoid that path reconciliation problem. I will say, though, that there's all sorts of stuff. The more complete you capture, the more data there is. And so there's a lot of advantages to not necessarily walking the same path, but kind of maintaining coverage over time. But that's really just up to the customer in terms of what they need and how much data coverage they actually is necessary for their use case. But for us, it really doesn't matter.
And that really comes back, at least I'm assuming, somewhat to SLAM, right? Where you're good at locating something, even if you're moving around a little bit. It's able to kind of say, actually, this is where you are.
Well, it's certainly SLAM, but again, a lot of the other algorithms that we have put in there to compensate for where kind of off-the-shelf SLAM doesn't work, which really doesn't work that well kind of on its own. And so it's just that when we designed that spatial computing platform to learn, we kind of built in the fact that they're not assuming any kind of consistent walk path because we knew that would be overly restrictive for customers.
Love it. So here's another good one. Are you able to quantify, and actually this speaks exactly to something you guys talk about, will you be able to quantify components on a site before and after, during and after rather, construction, like number and type of bolts, connections, and so on? Again, I think you guys are marketing something like this, but it'd be interesting to hear, A, your thoughts on it, but B, the limits, because sometimes things are hidden or they're it's dark or whatever. How do you guys think about that?
Yeah, I mean, that is definitely something that we're developing and really, again, really adopting this approach of a spatial AI assistant. So the idea that humans are always going to be part of that process because you want that human verification as part of that. I mean, it's an important task in order to quantify progress on a job site. So humans, you want them involved in that, but you want the machine to be able to speed that process up and make it as fast and efficient as possible. Now, in terms of the kind of limitations there, in general, you're limited by what's visible in an image, right? And so you can kind of get a sense of if it's too small to really see accurately, like, bolts, or if it's occluded, if it's behind something when you happen to take the image. There's really kind of not anything that you can do about that in terms of, you can't solve that with algorithms. A certain sense is just, you want to make sure what you're capturing is visible and there's light and clarity like that. But, certain things are always going to be outside the scope of what you can do just with images. like tiny bolts.
And maybe an analogy is when someone's doing a walkthrough, they might have and they might say, oh, that looks like it's done, but then they would walk up and verify or ask somebody and so on. So it's not able to intuit magic. It's just able to do what you as someone walking through could say, all right, that looks like this. Is that a good analogy for it?
Yeah, or even, you know, the final check is always going to be a system test for anything that you're developing. You're not going to get a kind of visual walkthrough that's going to let you know that it's actually working correctly in a system test, right? So you have to separate what is possible from visual inspection versus other types of inspection, you know, like you're describing.
Yeah, that makes a lot of sense. So there was a question, and I think we've kind of covered it, but I want to make sure we ask it. When we see technology that tells us what's installed and if it's installed to plan. So that is, we didn't talk about it. It's actually comparing it to presumably a BIM model.
Well, that's actually, yeah, very relevant to what we were just talking about. And is really just like another data point that we can take in, which is a very helpful one, of course. So integration of the BIM model into our product, which is something you can do today, but as part of that process of checking progress, is something that can be very useful, especially for like MEP trades in particular. And so that's definitely something that is that we are pulling in and using. But it doesn't solve that bolt problem, which is just, you know, the bolts are going to just be too small, even on the BIM model. But yeah, that aspect allows you to get a lot more specific in what you're quantifying if you have access to that level of detail in the BIM.
This speaks to process though, doesn't it? Is that you have an entirely new capabilities. So it's how are you, as the field team, how are you evolving process that enables this and uses this without saying, okay, it's replacing somebody a human going through and doing a full kind of, you know, going in and looking, you know what I mean? Like how are we thinking about a process with this new tool that augments what we can do and really multiplies how many hours in a day we have?
Yeah, you know, I mean, it's a great question. It is probably specific from process to process, with each one kind of having different requirements. But I would say at a high level, you know, it's always best not to kind of force people to change their process. That's always harder to push like a change of process onto people, as opposed to, again, making the processes they have much faster and more efficient, right? And so that again gets to this heart of this assistant approach, is really just taking what people are doing today and making it much faster and better. Now, there are always going to be opportunities to say, hey, this process doesn't need to happen anymore because this other process is now so much more efficient or so much more accurate. And so we're always looking for double wins like that. But in general, with, you know, software development in general and product development in general, the less you're kind of changing what people are doing, the more you're just kind of helping them do what they're already doing, the more adoption you get. And that's kind of one of the keys to our adoption, even just in reality capture, where people are already walking the job site, right? They're already doing inspections. They're already out there seeing what's going on. And we want to make it just super easy to, you know, attach a video to what they're doing. So we're kind of not changing their processes so much as augmenting it.
Yeah, love it. I've got two more questions and I think we'll say thank you. So one question was, are you looking to feed data with any existing BIM products? Obviously they're from Autodesk, meaning presumably Revit, but it sounds like yes, but how do you interface with BIM products?
So we actually integrate with Forge right now. It's Autodesk BIM viewer right now. You know, there's a kind of wide variety of integrations we have. We have an integration with Revisto that also has a lot of BIM, has a BIM viewer, a lot of integrations there. You know, future ones coming out. Again, way we think about that is really following our customers' lead and looking at what the processes and workflows that our customers have today.
Yeah.
Sometimes you can get away with just like a download, right? That makes it easy to kind of spread it around. But oftentimes you really do want a direct integration with a particular piece of software. And so we just listen to our customers and really are just trying to identify, you know, what are the integrations with other softwares that are going to be most beneficial for the most number of our customers.
Love it. Last question. So there's a question about resolution of the video frames that you're getting or the video inputs, how sensitive you guys are to that. I mean, I think at certain points you guys have specified what they should use, right? And I don't know if that's still true or if I got that wrong, but how do you guys think about resolution as an input?
Yeah, well, the more the better. So the higher the resolution, the better for us, for all of our systems. And so we tend to integrate with cameras that are kind of top of the line cameras, the ones that have the highest resolution. And again, this is because our customers also want the best resolution. And one of the things that we actually founded the company on was this belief that camera technology had and would continue to improve rapidly over time. And that's both the proliferation of cameras, so the idea that everybody now has a camera in their pocket, but also just the kind of hardware. Lenses will get better and cheaper. 360 cameras would get faster, more robust, and that really has proven to be the case as cameras continue to come out that are better and better. And so, our system works with a range of cameras. So if you're not interested in the highest resolution, or you care more, because obviously the higher the resolution, the bigger the video files, if that's less appealing to you, then we support a number of cameras like that as well. But in general, yeah, higher resolution is gonna be better.
Well, listen, Michael, thank you so much. There's one or two more questions, but folks that are asking them, I just read them. I think you guys should connect with Openspace directly, because you're asking now about pretty easy to, not easy to answer, but pretty product specific. I think they've got a pretty good team who can help you think through some of that. Some of it was frame rate and so on. Michael, this has been fantastic. I obviously nerded out a little bit and could do this for another hour.
I love it.
Yeah, thanks for walking through what you guys are up to, and I love the idea of spatial AI and everything you're doing. So thank you.
Absolutely. Thanks, Hugh. It was fun. Thanks for having me.